Hi everyone. Today we are going to talk about 4.8a complex numbers. So after lesson, you will be able to simplify square root of negative numbers by using imaginary number I. So before we start the lesson, can you do the do now? So solve the equation below by quadratic formula. So here's a quadratic formula given. So I'll give you about 4 minutes. Can you do it? All right, let's go over it together. So to use a quadratic formula, what should you do? You should figure out what is A, B, and C, right? So what is A, B, and C? A is 1, B is 3, C is negative 10. Then you put this into the formula. What do? Negative B plus minus square root B squared minus 4 times A times C negative 10. Remember, when you multiply, you better use a parenthesis. And also, when you plug in, always put the parenthesis so that you are not confused, especially when you have negative numbers and 2 times 1. Now, what should you do? You simplify. So, negative 3 and 3 squared is a 9, and negative become positive. 4, 1, 10. If you multiply, it becomes 40. Or you put everything in the square root, without square root, I mean, okay? Put the things 3 squared minus 4, 1 times negative 10 in the calculator. You can do that, and calculator will give you 49, right? Then it will be square root of 49 like this. Now what should you do? You need to simplify. Square root of 49, oh, it's a very simple one, right? So square root of 49 is what? 49 is a 7 square, so it become negative 3 plus minus 7 over 2. Now, what should you do? Separate into the two fractions, right? By using the common denominator 2. So negative 3 over 2 plus minus 7 over 2. You cannot simplify numerator denominator, but we know that plus minus is what? Two solutions combined. So you need to separate. So if you separate, one is negative 3 over 2 plus 7 over 2. The other one is negative 3 over 2 minus 7 over 2. Oh, now you can simplify this, right? Then, because you have a common denominator, you can add a negative 3 and 7, which is 4. You can add a negative 3 minus 7 is negative 10. And then eventually this will be 2, this will be negative 5. So because the question asks you to use the quadratic formula, you're supposed to do this way. If not, you can use the Kim's method or just factor and solve the zero, find the zero, right? Okay. So now we'll go to today's lesson. So before we talk about complex number, you should understand what is imaginary number. I. When we write down imaginary number as I. So what is I? A number such that I squared become negative 1. Or square root of negative 1, we say I. In the real number, any number, if you square it, negative, positive, doesn't matter. Always it becomes positive, right? In the real number, it becomes already positive if you square it. But I square, imaginary number, if you square it, it becomes negative 1. Negative. So it's not real, it means, okay? So we made a number system like this, which is not real. Sometimes we need it. So how do you express it? As a negative I, and then if you square it, let's say this becomes negative 1. And then as a definition, I square is a negative 1. but square root -1 equal to I. If you put the square root -1 in the calculator, what does calculator give you? Error, right? Because it's not real. Square root cannot have negative in the, in the square root. So it should be always positive to be real number, but it's negative. So this is I. Just notice you can write down the negative comes out as I. All right. So these are the examples. I, 7I, -12I, I cube, power I to the 7 power. Or you can use the square root in the square root negative numbers. And one thing we should remember is imaginary numbers, you cannot compare each other. It's not real numbers. Real numbers, you can compare which one's bigger, which one's smaller, right? But imaginary number, you cannot compare. So what's bigger? I, 7I. It looks like 7I bigger? No, 7I is not bigger than I. We cannot compare, we cannot measure them, right? So you cannot compare I and 7I. All right? So look at this. These are the real numbers, right? And square root of 2 and pi, these are irrational numbers, right? Irrational numbers also real numbers. We can compare each other. So square root of 2 is like 1.414, something like this, right? And then pi is 3.14. Which one is bigger? Pi is bigger. So you can compare here. But imaginary number, you cannot compare. And you should know I is I, but I square is what did you say in the definition? I square is a -1, right? Then based on the exponent, I to the third power is, if you know, is I square times what? I. So I square is a negative, so I third power is negative I. Do you understand? So -1 times I, because I squared times I is I to the third, it becomes negative I. Then I to the fourth power is what happened? Negative I times I, right? Because I to the third power times I, so it becomes negative I squared, and then I squared is a -1, so negative become +1, 1. Now you see I to the fifth power is I to the 4 times I, right? Think about the exponent. I to the fourth times I to the 1 power. So add the power, 4 plus 1 is 5, right? So I to the 4 is 1, so it becomes I again. It keeps repeating like this. I, 6 is -1, negative I, 1. Do you see that? It's a pattern. So every multiples of 4 to the in the power, it becomes 1 here. Everybody understand, right? But I needed to definitely understand up to here, I to the first power, but look at the pattern. But and I, imaginary, I square is -1. Don't ever forget this. And then we'll go to the complex number. What is the complex number? It's a combination of a real number and imaginary number. Real number and imaginary number together, how do you write down? Example, 3 is a real number, or 0, you can see here 0, right? Then when the real number part is 0, you will have only the imaginary number part. So -5y is imaginary number. Right? Or this is square root of 5 is irrational, which is a real number, but combined, multiplied by imaginary, this is imaginary number then. If imaginary number was multiplied to the real number, it becomes imaginary, we say. Anyway, this is a real number, this is imaginary number. Real number, imaginary number, you cannot combine, all right? You cannot combine. You should keep it like this. And today we are going to, so you cannot combine real number and imaginary number. Just leave like this. You can combine real numbers. You can combine imaginary numbers. But you cannot combine real number and imaginary number. Today we are, so this is the thing. Negative in the square root is imaginary, comes out as I, right? If you put into the calculator cannot do anything, give you error. So today we are going to simplify, right? We are going to practice how to simplify these kind of expressions. So let's think about negative square root 8 plus negative square root 32 plus square root 9. When you simplify these things, I want you to be familiar with the perfect squares. I gave you the example. One is one square, right? They are, so we call these numbers perfect squares. 4 is what? 2 square, right? How about 9? 3 square. 16, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, 10 square, 11 square, 12 square, and 169 is 13 square. If you remember, much better, you will be able to figure out very quick. So these kind of problems, you need to remember what the perfect square is. So when you do it, if you remember 8, 8 has a 4 times 2. There's a perfect square in it, right? As a factor, then you can simplify. That we need it. 32. 32 is what? It's not perfect square, but as a factor, which number? Below 32, look at 16 times 2, right? That is a perfect square, 16. You will be able to simplify. So how do you simplify? Let's go step by step. All right. So perfect squares, you should be familiar with these perfect squares. And then now, so square root of negative becomes I, right? So you can rewrite like this. Square root negative becomes I outside of the square root. Negative comes out of the square root. And square root 9 is 3, right? Square root 9, perfect square, right? Become 3. Now, we should simplify 8. Some numbers you cannot simplify, but you should check. 8 has a factor 2 times 4, right? Then 2 times 4, you can write down in one square root, 4 times 2 is okay, or you can split, doesn't matter. Square root of 4, square root of 2 is the same with square root of 8. So why did I separate like this? Because square root of 4 will become just 2, right? And then go to this one. 32. What did we say? 32 is 16 times 2. 16 is perfect square, right? These things will not be given, but you should remember it. So when you see the number 32, you should understand, 32 is 1 times 32, 2 times 16. 16, right? 16, the biggest one, all right? Biggest perfect square. 16 is a 4 square. But if you do the 4 times 8, what happened? 4 times 8, then you will do more. You square root 4 and square root 8. Square root 4 become 2, but square root 8 also you need to separate again. Eventually you will have the same answer like this, but you will do more work. So the best thing is you find the biggest perfect square, which is 16 times 2 instead of 4 times 8. If you do the 4 times 8, you go one more step, right? Because you need to separate, simplify square root 8 again. Okay, now if you simplify, square root of 4 becomes 2. And then you write down I here, square root 2. Don't do anything like this one. Now, this one, square root of 4, 16, square root of 16 become 4, and then I square root of 2. And plus 3, you don't do anything. Now, if you see that, square root 2i, square root 2i, they are the same, look same, right? Then it's like, it works like terms. Then we can combine these and these. So I square root 2, I square root 2. How many of them? 2 of them and 4 of them. So you combine these, okay? Then 2 of them, 4 of them, together how many of them? 6 of them. So 6i square root 2 plus 3, and you are done. So if you have image, you should have imaginary number, and this is irrational number, but they should have same form. Square root of 2 and square root of 3 is different, right? You cannot combine. But square root of 2, square root of 2, you should combine. But if you have an imaginary number, this one, if you don't have an imaginary number, this one, you cannot combine. All right? Okay. So this is error analysis. Can you identify the error, and then can you correct it? So you will have about 5 minutes or 4 minutes in your group. Can you do it together? So let's do it together now. Which step is error? Let's see the first step. Negative came out of I. Good. Square root of 36 is a 6 squared is a 36. It came out as a 6. Very good, right? And then you split square root 8. 8 is 4 times 2. Good. 3 times 6 is 18. Very good. And then square root of 4 became 2. So far, everything, and then everything good. 2 times 2 is 4. It's a multiplication. You can change the order. Doesn't matter. All multiplication, right? So you can multiply 2 and 2. 2 times 2 is 4i square root of 2 plus 18. Very good. And then 4 plus 18 is 22. Can you do this? No. This is imaginary number. This is a real number. So you cannot combine imaginary number and real number, right? So therefore, number 5 is wrong. Up to number 4 is correct, and you should stop here. Okay, so this is the answer. If you go down, right? If you go down, there's one more example here. You will be able to see. So if you need more, practice, you can compare with this one. Can you try by yourself and then practice by yourself like this? Okay. All right. So we are done here.